Hi everybody. Today what we're going to be doing is adding vectors in both the x and y form and I and j. Now, people watching this video, if you're watching this video, what I'm discussing here is how to use the component method of adding vectors. And so, for just as an overview, what we're going to be doing is taking these three vectors that we're given here, vector A, which is 20 units, right here, coming off at a 30-degree angle, vector B, right here, which is 40 units long, coming off at a negative 25-degree angle, and I'm going to talk about that later. That's a mistake, but it's important, and I left it in because I have something to show you all about that. We also have coming here at 180 degrees from 0, which is this side, according to, this is all based on the unit circle right here. As you can see, 0 degrees starting here on the x-axis. As you come around, vector C is 30 units long. So I have all our vectors here that are given to us listed. Vector A, which is 20 units long, is going to be in orange. Vector B, which is 40 units long, is in blue, and vector C, which is 30 units long, is in pink. Now, what we're trying to find out of this graph of three vectors that we're given is the resultant, and the way we're going to find the resultant is by adding the components of these three vectors together. And when you do such, by adding vectors, if you've already done the head to tail method of adding them, you then get the resultant, which is from the first tail to the last head of your vectors, according to, that's how Mr. Askew explains it, because if you're saying that this is the head of your vector and this is the tail of your vector, when you add all these vectors together in head-tail form, which means that you start with vector A, because we're just going to start that one alphabetically. You start with vector A. If you translated this over, just took this as if you could break it off, and you shifted it over at the same angle and kept its length, you'd put this tail of vector B, you'd connect it right at the head of vector A. And then for vector C, you'd take this one as if you could break it off from here. You'd move it with its, keeping its same length, and add it with its tail right here. Alright, so now we're at our second part. We've already identified our vectors, A, B, and C. Now what we're doing is finding the x and y components of these vectors. What that allows us to do is then add the components together and find the components that make up your resultant vector, which is vector R. If you remember from our previous page here, as you can see, we have vector R, which is green, we don't know it, in our three vectors that we do know, just like on page 1. You guys remember this from before. So, let's get to work. Here, starting with vector A is 20 units long. So, what we do to find a component is we take this, since we know the angle of our vector, we find, I like to start with the x component first, since your x is almost always your, starting with your x, and most commonly is your independent axis, so I just like to start with that one first. It also comes before y in the alphabet, so why not? It doesn't really matter that much, but that's just how I'm doing it here. So, vector A is 20 units long, and what we're talking about here is the hypotenuse of a right triangle. As you can see, that little square there, that's a 90-degree angle here, so this is a right triangle, which allows us to use our trigonometric identities in our trigonometric techniques to find lengths of these two legs of this triangle. So, starting with the x component, we do 20 units times the cosine, so 20 units times the cosine of 30 degrees. As you can see there. Then our y component is going to be 20 units times the sine of 30 degrees. So down here for component y, we're going to do 20 units once again, units can be whatever you want or whatever the problem states they are, doesn't really matter, times the sine of 30 degrees. Alright, so now you have your components, for your x and y components for vector A. Moving on to vector B, we have its x and y components. So you know the hypotenuse of this right triangle here is 40 units because it's your hypotenuse. This is vector B. So the x component of vector B will be 40 units times the cosine of 25. So we go x component over here in this table that I've made underneath vector B will be 40 units like so, times the cosine of 25 degrees, like that. Then to find your y component, you look over here, see your y component, your angle's still 25 degrees, so you do 40 units times the sine of 25 degrees. So you come over here, component y, go to your vector B column, and do 40 units times the cosine of 25 degrees, like so. And then do the same thing for vector C, but vector C, if you notice, has, because it's on directly, it lies directly on the x-axis, has no y component. So if it has no y component, then you simply place a big 0 here for, simply place a big 0 there for component C. It's hard to write at the edge of the paper, but as you go to component X, it's 30 units. But since, if you notice here, it's on the left side of the y-axis, it's a negative 30 units. Because this is components now. It's no longer just the vector. And since it's its only component, it's the full length of the vector, but now you get to make it a negative. So negative 30 units. Alright, ran out of room there, but that's okay. So that's it for finding your components of your given vectors. Now we'll come to the next part and show what we do next.